So last month was Charles Darwin's 200th anniversary birthday. And in celebration of that, I started thinking about what's happening in our own telecommunications industry, and are we at an inflection point where new species are being created? So I started thinking about that, and what are the evolutionary pathways that are taking place here? So the first one of the two that are primary in evolutionary pathways is natural selection. And we all know that natural selection is where a trait is beneficial to the survival of a particular species, it remains and a species survives. Where it's detrimental, those species die. Now, these things take course over geologic time frames. The other pathway is called genetic drift. Now, genetic drift is a bit different. It's an independent process, and it takes into account the frequency at which new traits are introduced and the probabilistic interaction of these traits to spawn new species. And it's this process that really is resulting in the creation of new species. The evolution of telecommunications has followed a fairly traditional evolutionary path around natural selection, and has taken a fairly predictable and long period of time in telecom. Early communication systems were point-to-point. Think about messenger systems. It's really hand-to-hand communications. I would take something, I would write it down, I'd run over here, I'd deliver that message, I'd commit something to the memory, and I'd run it back. But there was no medium, so it was very, very difficult to execute. We had other things like smoke signals. Now we're using photons, and we have an atmospheric medium, and things actually travel at the speed of light. But we're a bit limited because there's only about a 12-mile horizon, so we can't see too far. Smoke is really difficult to encode messages in, and there's no signaling layer, which made call setup quite challenging. We introduced the telegraph. Now, the telegraph gets electrons on copper, and that changes the whole range problem. But we're still suffering from a protocol conversion challenge. We've got dots and dashes that have to be interpreted to alphanumeric characters and back at the endpoints. And then after that, we go back to hand-to-hand communications. End users aren't going to learn Morse code, so there was never any incentive to deliver and build a capillary network. That's where the telephone comes in. Once we introduce the telephone, there is no more protocol conversion. You can just have an ear-to-mouth conversation on the telephone, so user adoption becomes very simple and easy, and that's when we started delivering the capillary network. That led to things like switching and routing, and that led to things like elimination of the party line and the elimination of the obsolescence of the switchboard operator. The next big innovation was digitization. Digitization enabled vast reductions in operating costs and improvements in efficiency in the network. This led to a separation of the media from the signaling layer, SS7, and the introduction of advanced intelligent network features. Now, once numbers are introduced, and that's what digital is, it's really the numeric representation of media, processors and coprocessors can now act with mathematical algorithms to do fancy tricks, if you will, forwarding, storing, muxing, and delivering messages in different ways. Now, these shifts from hand-to-hand communication through smoke signals, telegraph, telephone, into digitization really are just variations on a theme. They're the evolutionary process, but there's no great leap, no new species. We need something more, something that materially impacts behavior, something more than natural selection. Natural selection, however, in the internet, I consider to be true. The natural selection, the internet fossil record is already rich with dead organisms from the internet. And disruptive transitions occur in time frames like a year relative to things like biological eons or even in the telecom industry, decades. And it's changes in online consumer behavior that drive this. Think about the transition from Friendster to MySpace to Facebook. Once consumer behavior has changed, there's no stopping it. And it's this change in consumer behavior that defines the business models. Consider the arrival of SIP and voice over IP into the internet. It's probably one of the most significant functionality upgrades to the internet. And more significantly than the functionality upgrade, it's what it's taught us. It's taught us that any device can be a communication endpoint on this network. This is fundamentally changing the way consumers perceive and consume communications. A byproduct of this genetic drift, however, is pretty disquieting to the legacy carriers. For example, the virtual elimination of long-distance profits, the demise of incumbent carriers' walled gardens, and destabilization of the regulatory framework. On the other hand, Internet is introducing genetic drift into the telecom industry. Consider application stores or app stores, accessed over the Internet from a mobile device. This is a transformative phenomenon in the telecommunications industry. Customer behavior has been irrevocably altered. Customers now freely download applications to their mobile phones, something that they were absolutely loath to do just 2 short years ago. And this, too, has led to unintended consequences. Consider that AT&T has ceded software, hardware, and applications to Apple. They've essentially self-fulfilled the prophecy of becoming merely a bit pipe. And a whole generation has been taught that downloading applications is okay to these computing devices. That's led the way to new operating systems like Google Android. The result is that applications and devices are the defining differentiation, not networks anymore. Data and voice networks are constantly evolving and combining to form what I call the new DNA of communications. Phones and computers, as we said, are indistinguishable, and the space that was once occupied by the telephone network and the Internet is the new domain of this species. And no one single company can actually innovate quickly enough to take advantage of the expanded capabilities of this species. As communication services become programmable, and thus ubiquitously consumable, the number of programmable applications is going to explode. Phones, communication devices, won't exist like they used to. They will instead be communication instances. They will appear when and only when real-time communications are called for, and they will be software. And phone lines will be bit streams. Phone instances will be owner-independent. My phone might be, at any given moment, be your device, your PC, a car, an airline seat, a video player, a PDA, or a game station. It will be whatever it is, whenever it is that I need it to be. Business applications will be designed from the start and programmed with real-time synchronous and asynchronous voice features, communication features embedded, leveraging personal preferences of customers, and those personal preferences will be stored in social network constructs on the Internet. Now, this voice-driven human interface command syntax I'm talking about, that will be actually in the network. And natural language will be parsed and recognized by software. And the network will have control agents that will listen to that software and act on the behalf of the user, and will act on behalf of the semantic social web to do our bidding. These communication features and functions are going to be universally accessible. And the key is that they're going to be addressable through a multiplicity of what I would call common programming languages. Now, we, and I really mean we, as in us in this room, are the folks that are best equipped to see this kind of stuff. We have our eyes open to this evolutionary step, if you will, and it's a coming together of legacy telecom and the Internet. And it's not merely a transition through natural selection, it's more of a genetic shift towards a new species. We see evidence of this genetic shift every day. But like biological evolution, the magnitude of the evolutionary changes that we perceive are barely perceptible from our timeline. Since we're all here today, we have perception of this, and we perceive these radical changes are coming. But imagine what this evolutionary period is going to look like 20 years from now for our children and our grandchildren. Let's take ourselves out of the present for a second and look beyond the current generation. I predict that no one under 20 today will actually ever own a landline phone. They may use one, but they probably won't own one. And it's inconceivable today that today's 0 to 20 age group, which will be the productive group of society 20 years hence, it will be inconceivable that software-based communication widgets aren't freely available and just tradable and applied whenever and as needed. So the future of communications is software. Communications will be programmable. And this new species of communications will be a programmable species. And the users of this communications will be users that click, drag, and drop to talk. Now, we think about this a great deal, and Martin talks a little bit about this in his presentation. Everything that he described is something that can be achieved through software interaction with the communication network. So as we in this room and those of us in the industry start thinking about how we're making these changes, we're all talking about accessing communication features and functions through a software interface.